everyone. I'm Miss Hobbs from the STEM Academy,
Hi, this is Keel from the STEM Academy.
and we're going to talk to you today about energy transformations. So we have a lot of demonstrations for you today, so we're going to be jumping back and forth between the slideshow and the demonstrations for you, so hopefully you guys can play along. There are some basic types of energy. All forms of energy are going to be either potential, which means they're stored, or kinetic, which means they're in motion. We have chemical, mechanical, electromagnetic, light, sound, thermal, electrical, and nuclear. And we're going to be hopefully moving through each of these types of energies.
When energy exists, it can transform. It doesn't necessarily stay as one form or another. It can be converted. So, for example, you eat an apple, which is chemical energy, and then you go and ride a bike, and that turns into mechanical energy. Or chemical energy in a battery, which can be used to power a flashlight, which turns on a light, which is light energy. Actually, one step missing there. There's actually chemical to electrical, then to light. Sorry about that.
It is easy to miss.
And then,
Oh, I'm sorry. So we're going to go ahead and start off with a demonstration of the energy flow rings. So at this point, I'm going to go ahead and take off the lab coat so it works a little bit better. And these are called flow rings, and the energy flow rings basically just show you how energy can move from one thing to another. So when you put them on, they pop open, and this would be potential, and then as it moves, it would be kinetic. Potential and kinetic, potential to kinetic. Okay, so those of you that are listening at home, what kind of energy transformation is going on here? It should be, if you are potential to kinetic to potential to kinetic. Okay, now we're going to take a look at the centrifugal spinners. And see if you can guess what kind of energy transformation is happening here. What type of energy are we starting with, and what type of energy is it turning into? So let's see. We start with mechanical, and it becomes light energy because you can see this virtual reality bubble that's being created.
so here we have what are called energy sticks. What you have contact that goes on either end. So what kind of energy transformation is taking place? When you place your hands on the end, so what do you think is happening? Something with your hand related to when you're touching and making contact. And then the light and the sound coming from the energy stick.
Let's try this. So it's passing through us as well.
So, does anyone want to guess what kind of energy transformation that is?
And it is thermal to chemical to electrical to light and to sound. It's thermal because of the heat from your hand, chemical because there's a battery in the energy stick, electrical because we can get the electrons moving through, and light and sound are self-explanatory. All right, our next is the plasma globe, and we're going to turn the light out for this one so that you can see it a little bit better. Globe here we have, this is not actually real plasma, by the way. I think this is halogen gas, a type of halogen gas. I'm not sure which one. But you can see that the energy is being transferred. Oops, did it the other way. not wanting to glow for me. Let's do it this way then. And you can pull that up. And it lights up. It's kind of hard to see. You know, it's not quite dark enough, I don't think. We're having a little technical difficulties. Something that happens in science all the time.
Gotta keep trying.
Who can imagine what type of energy transfer is happening with the plasma globe? It is turning into electrical, to light, and then to thermal, because this energy globe does heat up over time. Not getting a good connection there. Well, try it if you have one at home. All right, here's an old favorite, which are the hand boilers. Okay, so what kind of energy transfer is happening here? When you first start out, the hand boiler, all of the liquid is at the bottom. Then as you hold it, you're creating thermal energy, which is then making the liquid move. So what type of energy transfer would you say this would be? Okay, it is thermal to mechanical. All right, this next one here, we had a little solar panel to the fan. Unfortunately, the fan didn't want to work for us today, so we substituted in something called a radiometer.
And the radiometer, when you take a lamp and put it close enough to, there's two different colored paddles on the top. And as you can see, it's beginning to spin.
So imagine this was the radiometer, and it's the same principle to it. What do you think is the first type of energy, and what do you think is being transferred to?
We'll pretend the lamp is the sun for all intents and purposes.
Right, so we'll start out with solar. Of course, we can't bring the sun in here, but we're using the light as an example because it's a strong, bright light, which is actually nuclear energy, to chemical to mechanical since it's moving. All right. Okay, our next example of an energy transformation is a fiber optic toy. Now these have batteries in them, and when we flip the switch, you get a nice color display. So what type of energy, since it has a battery, do you think it starts with? And since we can see the colors, what type of energy do you think it transforms into? Okay, this is a simple one. It's chemical for the battery to light for the fiber optic lights.
And now the lava lamp. Another great example of an energy transformation. So not only are they really cool to look at, but you've obviously started here with something that you've had to plug in so that you can obviously see the light. And then what happens? Not only do you have something moving around in here as well. So you have a light and something moving. So what kind of energy transformation have we started with here?
And be sure not to touch these at the top where the glass is because it gets very, very hot. So don't forget that in your energy transformation. Okay? This goes from electrical to light to heat, and then finally to mechanical because we have movements. All right, now we have some wind-up toys. All right, can you put the lights in?
Oh, they're getting away.
They are getting away.
Oh no! Wind up toys.
They're on the loose. All right, since we had to wind up these toys, What type of energy do you think we had to start with? And since they began to move, what type of energy do you think we ended with? We really should have had a bigger space for these, but it's okay.
It's an epic
We
wind-up
started
to a
out
battle.
with potential from the winding, which is really elastic potential, and then it became kinetic, which is another word for mechanical energy. All right, we're going to move to the caterpillar likes to go. We're going to move to the Van de Graaff generator. Miss Keel is going to be our guinea pig for this one because her hair is loose. What type of energy transformation do you think is happening in the Van de Graaff generator? There is a belt that is spinning inside. It is creating static electricity. And when you touch that, the static electricity should flow through the machine into your body. You can shake your hair just a little bit. Her hair is kind of raising up a little bit right now. These are not the best Van de Graaff generators in the world, but you know.
And we do live in Savannah, Georgia.
That's right. We do have a lot of humidity, which
It's
tends
humid.
to, make these not work as well as we would like.
And it
But
rained.
this starts from electrical to mechanical and then back again to electrical. So it moves and then it creates that current in your body. Okay, so we have a fun fly stick, which is a small version of a Van de Graaff generator, and we have a little piece of foil that you can now see how the electrical current is working, because it's creating a magnetic and electrical field that this little piece is attracted to or repelled by. So what are our energy transformations here?
Oh.
Uh-oh, there we go. It is chemical because there is a battery, to electrical because of the moving electrons in the generator, then to mechanical as this flies around the room. All right, now this one is very unique. It is called a Rubens tube. Lights off, please. What we're going to do here is we're going to put propane gas through this tube that has holes cut in or punched into it at regular intervals.
And you always want to make sure that you have your personal protective equipment, your lab safety gear. So we have our coats that we've been wearing through our demonstrations. And now we're putting on our goggles, safety first.
So what we're going to do is we're going to run music. Light this up, hopefully. There we go. And we're going to run some music through this Bluetooth speaker, and you will see the flames creating sound wave patterns so that you can see how the energy is transforming. Talking about in another video, wave formations. But right now this is energy being transferred from sound to mechanical.
And you can see the alternating patterns based on the type of sound that's being produced from the music.
It's vibrating the column of air inside the tube, which then makes the flame vibrate. Some good old rock and roll Chicago.
are making.
Want to give them one that they might know?
And maybe something that is a little bit more current and you might be familiar with. A little Daft Punk and Pharrell Williams. Thank you.
I like some Pharrell Williams.
Making the flames dance. So what type of energy transformation is taking place? So again, you start with the propane, you have the chemical energy that's creating the flame that then becomes mechanical energy for the sound to the mechanical energy of the flame. And obviously the speaker itself being the chemical energy in the battery that's being produced in order to vibrate the speaker. So there's also some online activities that can be done. A website called FET that can be used to do interactive simulations. And this is an example called Energy Forms and Changes. So basically, there's an introduction you can go into, and you've got different substances. You can click on indicators for the symbols and different substances that you can put onto heat sources and see the transformation and energy being exchanged from the heat as it heats up the different substances. You can start with a brick, and you can see the heat adding energy to the brick, and then you can transfer and move the brick into another substance. You can measure the temperature. You've got a nice little thermometer you can pull over to see, and then you can go and put it into another container and see the transformation of energy. Obviously, you can see the energy being moved into the water there. And then you can try out another substance. We've got iron. It actually takes a little bit more energy, a little bit more time to heat up the iron than it did the brick. Let's think about why that might be, what it is that's happening, maybe related to how packed in the molecules are of the brick versus the iron and why it would take longer to heat up. So then you can transfer that over to another substance. We'll drop it into the olive oil here, and you can see the energy being exchanged into the olive oil. But then there's a whole other part of this. So you've got your introduction. So now you can do some manipulation and change around, going from sources of energy. You've got a little wheel, we've got water, and we can turn on our energy symbols, and we can turn on the water so you can see water falling would be a good example of mechanical energy. You set it to play, and you've got your different symbols on the side that tell you what form of energy that's exchanging so that you can see that transformation. And you can go through and do that with a lot of different simulation. Let's see if I can move this video forward a little bit. And again, this is something that you can manipulate and play around with. You can sign in to FET and do the simulation yourself. We've got our solar panel working, so we just needed that one. We used our virtual sun. So we've got that, and then it's going to electrical energy and then into light energy and thermal energy. And you can even change out the type of bulb. You've got your incandescent versus your fluorescent. Then you've got your good old mechanical energy that you can use. So it's a lot of fun. These activities, obviously, they're interactive, and it's a good source as you have other places that if you're not in a science lab that you might not be able to have access to. Of course, it would be cool if you could hook up your bicycle to a wheel and then, power something. Everybody's trying to do their part to go a little greener and help the environment. And our good old tea kettle.
making that water evaporate and turning into mechanical energy, thermal into mechanical. It's a fun simulation.
Well, I hope you guys have learned something about energy transformations, and I hope that you can try some of these things at home, even if you are just plugging in a toaster or making your dinner for your family. There are all kinds of energy transformations taking place at all times. So next time you do that, I want you to start thinking about where did the energy come from and what did it turn into and what did you do to make that happen. We appreciate you being here and thanks so much. Bye.
Bye.